Right, in this video, we are going to take a look at what's called a phase plane equation for a system of differential equations. In particular, we're going to consider autonomous differential equations, meaning the equation for dx dt is going to be independent of t, and the equation for dy dt also will be independent of t. So when our differential equations, our system is non-autonomous, then this won't necessarily work for all of those systems. But for an autonomous system, what we're going to talk about in the next couple of videos, we can look at what's called the phase plane equation. So ideally, when we're solving a system of differential equations, ultimately what we're looking for in the end is a solution. How does x depend on time? How does y depend on time? And then we've talked about how we could plot those solutions, x and y, separately. So maybe we find some solution over here and we find some solution over there. And we've also talked about how we can plot solutions in the phase plane. And when I look at the two dependent variables, so that we looked at in the previous week's work. So I want to talk about in this video and in some of the future ones how we can solve at least the phase plane equation for a system of differential equations. Okay, so how we first of all find the phase plane equation. Okay, and so finding the phase plane equation is going to be an application of the chain rule. So just recall what the chain rule says is that if I want to figure out what the derivative of y is with respect to t, and I know that y depends on x and x depends on t, then I take the product of the derivative. So we have dy dx times dx dt is equal to dy dt. But if we are interested in figuring out how x and y depend on each other, then we can rearrange the terms in the chain rule to solve for dy dx. And so if I were to divide both sides by dx dt, then I can get the phase plane equation. So basically, the phase plane equation, we take the one differential equation for y down here, that goes on top, and then we divide by the differential equation that we have for x, and that goes on the bottom. So it almost seems like the dt's cancel each other out, like if we were dividing two fractions. But be careful, that's not exactly how this works. What we're really doing is using the chain rule and just rearranging the terms in the chain rule. Okay, so we call this resulting equation for dy dx the phase plane equation, since solving that equation is going to tell us what the solutions look like in the xy phase plane. So we'll take a look at several examples in the next couple of videos. But that's the idea behind how we can set up a phase plane equation. We just put the equation for dy dt on top and divide by the equation for dx dt on the bottom.